Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another South Korean College Scholastic Ability Test video, the test that South Korean high school seniors take in order to apply for the college. Today's problem is as follows. The graph of the continuous function y equals f of x is symmetric with respect to the origin, and f of x is equal to pi over 2 times integral f of t dt from 1 to x plus 1 for all real numbers x. When f of 1 is equal to 1, what is the value of pi squared times integral x times f of x plus 1 dx from 0 to 1? Alright, let's start with this integral condition. Here, function f of x is given as a definite integral where the variable x is located at the upper bound of the integral. If you have a fair amount of experience in calculus, you may know that one very useful thing to do with this kind of expression is to differentiate both sides. So let us differentiate both sides with respect to x. The left-hand side is f prime of x, the derivative of f of x. And if you apply the fundamental theorem of calculus, you obtain pi over 2 times just f of x plus 1. If you have trouble understanding this, then just let capital F of t be one of the antiderivatives of small f of t. Then, by the fundamental theorem of calculus, this integral becomes capital F of x plus 1 minus capital F of 1. Hence the derivative becomes capital F prime of x plus 1, hence small f of x plus 1. So from this result, we obtain f of x plus 1 is equal to 2 over pi times f prime of x. And we can use this to change the integral that we have to evaluate. So this integral changes to pi squared times, now we have additional constant 2 over pi, then integral of x and f prime of x dx from 0 to 1. Here we use integration by parts with u as x and v prime as f prime of x. Then we have u prime equals 1 and v equals just f of x. So now we have the constant part 2 pi times uv part is x times f of x minus integral u prime v is just f of x. So integral of f of x from 0 to 1. This equals 2 pi times, the first term becomes just f of 1 and minus integral of f of x from 0 to 1. It is given that f of 1 equals 1, so all we need right now is the value of the integral of f of x from 0 to 1. And we can use the given integral relation again. Aside from differentiating both sides, another useful thing we can do is substituting x with numbers. In this case, substituting x with -1 will be very useful because it makes upper and lower bounds of the integral 0 and 1. That is, f of -1 equals pi over 2 times integral ft dt from 1 to 0. Since the graph of y equals f of x is symmetric with respect to the origin, we have f of -1 equals minus f of 1, and since f of 1 is given as 1, we have -1. So this becomes -1 equals pi over 2 times the integral, and here we can change the integral from 0 to 1 if we add minus sign here, and instead of t, we can use x because it is a definite integral. This gives integral of f of x dx from 0 to 1 equals 2 over pi. So this value right here is 2 over pi. Therefore, we have the result 2 pi times 1 minus 2 over pi, which gives 2 times pi minus 2. Therefore, the correct choice is choice 1. And that's all for today's video. Thank you for watching. Please hit that like button if you enjoyed this video, and I will see you in another video.